Okay, so so let me go here. So I'm gonna go now to what it says week 7. So today, let me download it so we can write on it. That was just last class. Oh, by the way, I will set up. I haven't set up the quiz because since I have Wednesday, I'm just gonna open the quiz today, and it's gonna be on Friday. Okay. So I wanna move on. I wanna move on the topic so I can give you more homework. Oh, by the way, okay. Before starting, let me show you the homework because you guys need to be aware you have a lot of homework. So you go to web work. What's happened? The internet is bad or what? Okay. So you see you have matrix operations. So these are like 16 problems, but if you see the problems, they're very easy. They're just basically just subtraction of numbers. This is just like primary school. Adding matrices, adding, well, there are more equations here, but you know, this is basic operations. -4 times the matrix. These are a little bit, you know, you just solve for x, and these are matrices, so you can do all these operations. If you have any questions, let me know, okay? But I think they are very natural. All these operations are very natural. Oh, transpose. Well, this one is, we haven't defined it, but this is very easy. So transpose, this AT is transpose, okay? So that is defined like so maybe I should make a new page. Okay. So if you have a matrix A, let's say A, B, C, D, E, F, G, H, I. A transpose means whatever is a row, it became a column. So this is a column. So now I write A, B, and C. Now I have D, A, E, F. Now I have D, E, F. And I have G, H, I. Now I have G, H, I. Okay. So that's the transpose of A. Okay. So you have that operation over here. And probably you have more of those. Transpose, it's just operations. So, okay. And this one, this is the adjoint matrix of a complex matrix. So this is also just a definition. They said you have, so your entries don't have to be real numbers. They could be complex numbers. So for example, you can have 5 plus 3i, and then 2 minus 3i, and then you have 4 plus 5i, and then I, okay? So the adjoint is the transpose, but also the conjugate. Remember that A plus BI, the conjugate of that is A minus BI, okay? The conjugate because they are always together. A plus bi and n minus bi are like married because if a plus bi is solution of an equation, a minus bi also is going to be a solution of the equation, like what they call it conjugate. So the conjugate here, so this is the transpose and the conjugate. So you could write it like transpose conjugate. Okay. So you will be 5 plus 3i. Oh, let's find the transpose first and then the conjugate, okay? So first the transpose. So 5 plus 3i, 2 minus 3i, 4 plus 5i, and then I. This is the transpose. And now with the conjugate gives you 5 minus 3i. So conjugate means if the number is with the I, it becomes negative. 4 minus 5i, 2 plus 3i, and then minus I. That's what it means, okay? So let's solve this one, for example. So I'm gonna solve that one. Let's don't get scared. So this is the transpose and the conjugate. So it will be minus 5, and instead of plus 3i, what should I write?
Minus?
Minus 3i. Now here on the bottom, what should I write over here?
The same thing, but you switch the minus 6i for plus 6i?
Yeah, so 6 plus 5i. And over here, we minus 5, and instead of minus 6, plus 6i. And over here, that one is 1 minus 2i. Okay, so this one, the transpose, it stays the same, right? But since it's conjugate, we need to change it to minus. This is correct, okay? So these are just operations. So, okay, so let's go to more. Where I am here. So it's matrix multiplication. It's just multiplication of matrices. That was just kind of exam, the exam that we already passed, right? This one, more multiplication, how to write this system. So you already know how to do that. So this is, it's a lot of problems, but this is just more of the same stuff. Well, this one is a little bit more interesting. So what is A? Says that A times 100 is 523. A times 0010 is 5 minus 2 minus 4. A001 is minus 5 minus 1 minus 1. So I'll let you to try that. This is easy. This is also easy. This is interesting because you're going to see here that AB is different than BA. Okay? This is a very important from matrices. That's what they're useful in quantum mechanics, for example, because 5 times 4 equals 4 times 5. But in matrices, this is not true. They're not commutative, okay? So this is the same thing. Multiply matrices, see that they're not the same. More multiplication matrices. A lot of operation between matrices. This is multiply times 3 times A by itself. So A cube means multiply A times A times A. So you need to do that multiplication 3 times. Well, more questions. Yeah, so this is also, I only comment on the problems that are look a little bit new, but otherwise, I think it's very straightforward. And then linear transformations. What we did last class. So we have a lot of, I'm gonna download the hard copy just to go over that faster. So these are the, so remember that the linear transformation satisfies a property, right? So they wanna ask you if this is a linear transformation or not. So you're gonna have a lot of ask questions like that, okay? So is this linear transformation or not? So you need to check all those examples. So I'll let you try them, and then depending on the question you bring me, we will solve some of those. But first I want you to try to solve this and then bring me questions. So this is more like the way we were doing it. T of this, T of this, T of that. Find the matrix of A. So this is similar to what we were doing previous homework. So I want you to try it and to see what question you bring me, okay? This is interesting. This kind of start getting interesting. And you have a lot of questions, so. Okay, and then, where did it go? Wet work, okay. And then the last one, cohort sets. Properties of linear transformations. Okay, so this one, you guys are not ready for it, okay? This one is still not ready. Let me see. I mean, you kind of, you can try it, but probably you can wait a little bit. But this one, you still have time, okay? So I will try to solve some of these problems with you. So yeah, so so yeah, so today's kind of a special. I mean, I supposed to record the class on Friday, right? Usually record. So let's do some of the problems that I show you here, so you guys can advance in your homework. So let me go back. Instead of moving to inverse transformation that I was planning to do, let's go some homework problems. So on Friday I finished that hour. Let's see. So let me show you one more example. And then I'm gonna make the quiz available, and then you guys can start working on your quiz in the time that we have left. Okay. So I want to do a few of these linear transformations. So matrix operation, matrix multiplication, you go for it, okay? You are ready to solve that one. I'm gonna do a few of these. Okay, let's do this one. So we define f of x equals a of x. Is f a linear transformation? So let's do it. Okay, so we got. So what does it mean, linear transformation? So a linear transformation means f of, it could be two properties. Probably it's easier like that. I usually like it like that. Property one, f of x plus y equals f of x plus f of y. And second property is the constant can go out. So c times f of x. Okay. That's a linear transformation. You need two properties for that. Okay. So the problem is, example, or the problem from Wellbor is f of x equals a of x. So what is f of x, property one? What is f of x plus y, guys? What is f of x plus y? If f of x equals a of x, what is f of x plus y?
8x plus 8y.
Yeah. So is f of box is 8 times box. So f of box is 8 times the box. And what is inside of the box?
X plus y.
X plus y. So you multiply ax plus ay. Okay. And then that's first part. So it says, what is f of x plus y? So you can write ax plus ay, right? And now, what is f of x?
8x.
Ax, correct. Ax. And what is f of y?
8 of y.
8 times y, yeah. So are they equal? Are they equal or not? F of x plus y equals f of x plus f of y. Are they equal?
Yes, sir.
Yes. So choose here. Yes, they're equal. Okay. Now, that's the first property. The second property, f of cx. So let's do it here. So second property, f of cx what is it? What is it? F of box is
8cx.
ACX, correct. And now the other one says C f of x. C f of x. So what is f of x?
8x.
AX. So is it the same ACX to CAX? Is the same or not?
Yeah.
Yeah, because they're numbers. Since they are numbers, they are the same. So we get ACX. And here we got C AX. And that are they the same? The answer is yes, Erico. If it's F linear transformation, yes. Because they are the same. And so it satisfies the two properties of linear transformation. Okay. So next problem, same thing. So you do it. And this one. Yeah, so you try it, okay? And the one that I want to do is this one. T of 1, 0, 0 is four, minus 4, minus 2, minus 5. T of 0, 1 is that, and so on. So I guess I'm gonna write it down here and pass it. So let me write it down here so I can write it on the OneNote. T of 1, 0, 0 is minus 4, minus 2, minus 5. And T of 0, 1, 0 is minus 1, minus 1, minus 3. And then T of 0, 0, 1 is minus 4, minus 1, minus 4. Minus 4, minus 2, minus 5. Minus 1, minus 1, minus 3. Minus 4, minus 1, minus 4. Yeah. So the question is, what is A? So the question is, what is A? Remember, T and A is the same thing. Okay. That's the fundamental theorem of linear algebra. Okay. So question. T is a transformation from which space to which space? It goes from here to here, to where? So for example, T takes 1, 0, 0, and it gives me minus 4, minus 2, minus 5. So what is the domain of the transformation? R, R2, or R3? Or R4?
R3 to R3.
This R3 to R3 because it takes a vector from R3 and gives me a vector from R3. Okay. So question, what is the dimension of my matrix?
3 dimensions?
Say again?
Oh, it'd be 3 by 1?
No.
No?
So this is the trick, guys. So remember, if let's say you say 3 by 1, right? 3 by 1, and this is a 1, 0, 0 is what? 3 by 1. So you cannot multiply these two, right? So this T needs to have, this number has to be the same than this one. So this needs to be a 3. And now, the outcome, this is a 3 by 1, right? So the outcome has to be the same here. So this is to be a 3. So the matrix is a 3 by 3, but that's something, it's just something you with practice you learn. So we need to find a matrix A, B, C, D, E, F, G, H, I, such that times 1, 0, 0 gets me minus 4, minus 2, minus 5. So what do you get? When you multiply this matrix times 1, 0, 0, what do you get? This times this, what do you get? What is ABC times 100?
Oh, it'd be A.
A. What is DEF times 100?
D.
And what is GHI times 100?
G.
G. And this is -4, -2, -5. So there you go. You got your first column. So that's your first column. The second one is A, B, C, D, E, F, G, H, I times 0, 1, 0. So what is this? A, B, C, D, E, F, G, H, I. Okay, so but in the problem it says that this 0, 1, 0 is -1, -1, -3. Yeah. So what do you get, guys? This guy times this one, what do you get?
BEH.
BEH. And then this is -1, -1, -3. And then the last one. So you guys can guess what is gonna be CFI. What is gonna be CFI?
-4, -1, -4.
Correct. So this is a trick. So what they're teaching you is a trick to find your matrix. You wanna find your matrix? Just evaluate the transformation of 1, 0, 0, 0, 1, 0, 0, 1. This is an amazing trick, okay? Because this is an abstract transformation and you can define it as a matrix. So that's what I wanted to do this problem. So -4, -2, -5. And this is -1, -1, -3. And this is -4, -1, -4. This is a really good one for the exam, guys. Because I don't give you the T and you have to find me the matrix. So all that you need to do is evaluate 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you'll get the matrix, okay? Then you have similar. Oh, those are look a little different, but these are the same. Yeah. So I think we are ready then. So you can, so please start with those two homeworks, because I think the second exam is coming soon. So on Friday, I'm gonna teach you how to find the inverse of matrix. On Monday, I'm gonna teach you determinants. And then on Wednesday, I should do some subspaces and we're ready for the second exam. So by Wednesday, I'll finish the topics for the second exam. So no, we could do the exam before spring break. We'll see. We'll see what you guys want. Okay, so I think I can stop now, since I'm gonna do another on Friday. I'm gonna have the rest of the video, but I wanted to do a video for the homework, so you guys can have you guys have a lot of help to the homework, so you guys don't get behind. Okay, Any questions? I'm gonna make the, give me 10 minutes. I will set up the quiz so you can still work on the quiz, okay? You will have 30 minutes to the quiz because you wanna finish it today. But I'm gonna make it due Friday for everybody, Friday afternoon. But if I was you, I'd just do it now in the class, okay? Any questions? No questions? Okay, guys. So I'll let you go, and then you can start your homework too. Okay, bye. Thank you for watching.